3 is bigger than 2, so that's another comparison. Then 4 with 3, okay, 4 is bigger than 3, so you know where it goes. That's another comparison. 5 with 4, well, you know where it goes. So once you've compared 5 with 4, you don't have to compare it with 3. You know that 5 fits after 4. 6 with 5, that's another comparison. 7 with 6, that's another comparison. So how many? 1, 2, 3, 4, 5, 6. So 6 comparisons altogether. Let's see. Should put a 0 in there to begin with. So 1 with 0 to start with. So we've got 1, 2, 3, 4, 5, 6, 7, 8 things in the list, and 7 comparisons is their best case, which is just 1 less than the number of lists. So that's really what this is saying. If your list is already sorted, you only need 1 comparison at each step. And if you had 8 to begin with, you only need 7. On the other hand, what's the worst that could happen? Well, the worst that could happen would be four, 3, 2, 1, 0. What's the worst that could happen? Well, the list that's actually in the opposite order to the one that you want to put it into. So you think about this as the worst case. Okay. Well, let's count. That's the initial list. You compare 6 with 7, so that's 1 comparison. So we now have 6, 7. 5, 4, 3, 2, 1, 0. Now, 5 compared with 7, then 5 compared with 6, so that's 2 comparisons. So now we have 5, 6, 7, 4, 3, 2, 1, 0. Then 4 compared with 7, 4 compared with 6, 4 compared with 5 to get 4, 5, 6, 7. How many comparisons do we make? 1, 2, 3. 3 comparisons. And our unsorted list is 3, 2, 1, 0. Now you can guess what's going to happen next, can't you? 3 compared with 1, 2, 3, 4. You've got 4 comparisons there. 3 with 7, 3 with 6, 5 with 4 to get this bit into that form. How many comparisons? 1, 2, 3, 4, 5. So 5 comparisons. I'm being a bit tedious, but I think it's actually really worth it in this case. How many comparisons? What? Yeah, you can see 6. 1, 2, 3, 4, 5, 6 comparisons to get you into. Oops. And then finally, that 0, you need 7 comparisons to get you into the final sorted list. How many altogether? 1 plus 2 plus 3 plus 4 plus 5 plus 6 plus 7. And we've actually seen that in the past, so 1 plus 2 plus 3. So that's the very worst that you could do. You couldn't get a list in a worse order. That's what's happening here. And if you total it up, it's 28. So at 23, in a sense, was a fairly muddled up list, nearly as many as you actually need in the worst case, and far more than in the best case. So apply to 8 numbers. 7 is the best number of comparisons, the complexity of the problem. So if you've got your list already in order or very close to it, then you're going to have the fewest or the smallest number of comparisons. The worst case is if it's actually in the reverse order, and then you get this sum, 1 plus 2 plus 3 all the way up to n minus 1 comparisons. If you remember, n is the size of the list. And we've actually talked about, I think we talked about 1 plus 2 plus 3 plus all the way up to n minus 1. And well, if we, can somebody remind me if I did this? I would have done it at the board a couple of weeks ago. Does anybody remember? No? Yes? Okay. Let's see. Suppose I ask you, what is 1 plus 2 plus 3 plus 4 plus 5 plus 6? Yeah, let's just go that far. Oh, actually, let's even just go that far. Well, one way of doing it is 1 plus 2 plus 3 plus 4 plus 5. Okay. So if you add up the number of dots, 1 plus 2 plus 3 plus 4 plus 5. But you realize that you can also get 1 plus 2 plus 3 plus 4 plus 5 this way. Let's put 1 there. I've done this in red. 2, 3, 4, 5. So I've got here in red 5, starting from the top, 5 plus 4 plus 3 plus 2 plus 1. So in red, I've got 5 plus 4 plus 3 plus 2 plus 1 little red circles, and I've got the same number in grey. Now, how many have I got altogether? Use a different colour. How many circles do I have altogether? Well, I've got 1, 2, 3, 4, 5 rows. And how many columns? 1, 2, 3, 4, 5 columns plus another one. So I've got 5 times 6. I've got 30 dots altogether, both red and grey. But those 30 dots, I've got the same number of red and grey. So altogether, if I take 1 plus 2 plus 3 plus 4 plus 5, those grey ones, plus the 1 plus 2 plus 3 plus 4 plus 5 red ones, I get 30. So how many do I have just in this group? Well, I must have half of 30. So this is a half of 30, or that's also a half of 30. So you can see that there's nothing really special about 5. I could have had better do it this way. I could have had 1 plus 2 plus 3 plus 4 plus... I can end it an arbitrary number. So the way I do it is 1 there. In there. Then I fill out the triangle in reverse order. So in this triangle, I've got, I'll do the red one first. So in the red triangle, I've got 1 plus 2 plus 3 all the way up to n. In this triangle, I've got 1 plus 2 plus 3 all the way up to n. How many have I got altogether? I've got n rows, n plus 1 columns and twice as many dots as I actually want to count. So what I end up with is if I want to add the integers from 1 to a particular number, I say that number times that number plus 1 divided by 2. For example, I'm sure we did this somewhere along the way. So if I want to add up the numbers 1 to 10, I've got n equals 10. So this is going to be 10 times 10 plus 1 over 2, which is 10 times 11 over 2, which is 55. Now, without actually having to do the counting. Now, we're going to do something a little bit tricky. Going back to this, we had eight things in our list. How many steps in the worst case? 7. 1 plus 2 plus 3 plus 4 plus 5 plus 6 plus 7. So we're actually adding not up to n, but up to 1 less than n. So we're actually, instead of adding up to 8, we're adding up to 1 less than 8. So what we want is how many steps are required in the worst case with n inputs. It's going to be 1 plus 2 plus 3 all the way up to an add up to 1 less than n, rather than adding in the last n. So this formula that we just did, okay, basically says that if we want to add up everything as far as that, we take the end point times 1 plus the end point divided by 2, so that's n times n minus 1 over 2. Okay, which is n squared, so n times n is n squared, n minus, that's n divided by 2, and if we write it out this way, a half n squared minus half n. So that's the worst case. If you've got n things in your list, insertion sort will take at worst, at most, a half n squared minus a half n. What sort of order is this? This is order n squared. So we don't worry about the half, we worry about what's the largest term. The largest term is the n squared bit. So what we've just said really is that insertion sort is a order n squared algorithm. And if I've done things right, that's essentially what these two slides have done. That's the last slide of lecture 19, is the worst case of insertion sort. What's the worst that can happen if you've got, remember, n is the size of the list. The worst case is that you have to do this many comparisons, and adding up that is basically a half n squared minus a half n, which is order n squared. Okay. So what we'll do now is let's have a short break for 5 minutes. Come back in 5 minutes and we'll have a look at the next lecture. My notes. Just
Can you let these dry just a moment?
13.
Did you put them in the dryer?
Why are you not at work?
Oh, this is lecture 18. Sorry, we'll go on to lecture 19.
Cool.
2 people got it.
Right. So if we stop for 5
really
minutes,
wanted to
come
go
back at I've got 2:02, so let's come back at 2:07.
Yeah, did you put
Get a
them
cup of tea. I
and
certainly
the
need
other
a
stuff, or is that?
short break, and
just-
we'll finish
I was
this.
cleaning the toilet.
Finish
and
off the
I
next
poured,
lecture.
You
so
know,
we'll
the thing? I poured
well
that
and truly
into
ahead of ourselves.
Spilled into my Ugg boots and onto my pants, so I put them in the wash.
Oh, so
And
they've
onto
been
that
through
mat.
the wash.
So they've been through the wash. They're dirty.
Do you mind if we just let them dry now?